We are live now.
All right. Welcome, everyone. Welcome to yet another meetup for the Logged In Together but Better virtual meetup sessions. We have a new calendar, and we are today is May 17th, and we are doing the contemporary C++ by Kuntal, aka Hello Z. And we're looking forward to learn new ways to work around with C++ programming language. So that's the topic for today. The platform is Jitsi, as we all know. So without boring you again with all these talks, I'm gonna talk a bit about the code of conduct. So, in short, the code of conduct is to just be nice with everyone, and that is applicable for these virtual meetups as well. You can read the entire COC in this link. So just set your display name under the settings, follow the COC, mute your microphones. If you want to ask a question, just put in the chat window, or you can ask directly by unmuting your mic if speaker allows that. If you want to propose similar session, you can do that on the ILUG-D GitHub Talks repo. And that's all. So we have Kuntal today with us, and you're going to talk about different contemporary ways of using C++. So over to you, Kuntal. Take it away.
So hi, as you know that I'm Kuntal and I'm going to talk about how to approach modern C++. So the first thing would be about me, and I am a final year undergrad at Delhi University, and I'm contributing to KDE for the last couple of years, almost 2 years now. And right now I am working for Lumix, where we do a lot of QML and C++. So, so a couple of days back, I went to YouTube and saw a video which said, "Why do I not recommend C++ in 2020?" So, and I clicked on the video and just went to the comment section because I knew about the content. It should be most likely there are not many jobs. It's not good as Python or something else. So in the comment section, a lot of people were talking about that. C++ is mostly seen in schools and colleges, and it's academic language now. So talking about the academic aspect of C++, from an Indian perspective, we all have seen this. From our school curriculum has computer science, which runs this Turbo C++, and even if you're in college, you would see this screen. So my first recommendation would be to play to please not use this and move to a more better compilers like GCC, Clang, MSVC. GCC is the GNU compiler collection, and it has a C++ compiler called G++. This is mostly for Linux. There is a port for Windows, but I'm not sure it is as good as the Linux one, and I'm not sure that there exists a Mac OS port of it or not. Next would be Clang. The Clang is a front end for the C++ front end for the LLVM compiler infrastructure. LLVM is a project which provides a lot of stuff to write your own compiler, and Clang is one of the front ends for the C++ ones, and some other front ends Julia, as far as I remember, and probably Rust 2. Some other less popular front ends would be Haskell and Go. Last but not the least would be MSVC, which is the Microsoft Visual C++ compiler. So it's only available for Windows and comes with the Visual Studio. The one unique thing about MSVC is it breaks ABI compatibility with every major release. So ABI compatibility is like you have written a code for Java 5, and it won't run with either Java 4 or Java 6. So it would run only with the Java 5 runtime. And similarly with MSVC, if you compile the code with the Visual C++ released in 2012, it won't run with any runtimes from 2013 or 2011. And that's that's one of the downsides of it. Other than that, is the best compiler for Windows. And one more thing, talking about Windows, Apple ships Clang with the Xcode development kit, I think is called, and but they include a lot of custom patches of their own, so it might be a bit different. And other than these three, there are some proprietary compilers like the Intel one. There is one of the IBM, and Mentor Graphics also has one, as far as I remember. So coming back to the talk, we'll start with modern C++ is all about writing less code, express more in less code. So we'll be starting with the hello world right now. And what you see in the screen is a legit C++ hello world. So if you take a look at this code, you would see it's more likely a C hello world, but it compiles with C++ compilers. Because C++ is mostly compatible with C, but not exactly C. Because as you see in these two functions are same and different at the same time. Because if you write answer 190 90, it would work in C, and if you write answer 1, it would too. Because any function without any parameters, mean any number of parameters can be passed unless and until you mention a void in C. In C++, this is invalid because both the function would be same in C++, but in C they are different. If someone has written Linux kernel modules, they would know that the kernel modules have a signature which includes this void. So a canonical C++ hello world would be somewhat like this. It uses a string, std string, and uses strings for printing out the variables. It could be cleaned a little bit more using something like using namespace std, which I don't actually prefer. Instead of this, I prefer using auto. But if since you have used auto, it would evaluate to a character pointer, which we don't seriously want. We are avoiding pointers right now. So to fix that, there is one more thing you could do is std string literals and do an s, then it would evaluate to be a string. More accurately an std string. So that's I got this things from a talk which I found on YouTube last a couple of days back. It would be this one. So this talk mostly talks about if you have a C++ course, don't teach C first, but build on the C++ fundamentals like std string, using iostream and stuff like that. And then in the advanced part of the course, add C stuff. Because C and C++ are different a lot. So the coming back to the main thing, as I said before, modern C++ is all about avoiding raw pointers. So the first thing that comes to our mind is, how do you do polymorphism? So the answer, I think I have it. Okay, this is a basic polymorphism example where you have animal, then cat inherits from the animal, and the animal in dog inherits from the animal. There's a sound method which gets overridden by the cat and the dog, and you pass it this like this. So if you run it right now, it would be most likely it would print bar. So as expected, but here you can see a bit of problem because we don't free the memory here as we allocate for memory for new dog. So a smart way to avoid that would not be allocate a memory and declare it on stack, and instead of a pointer, declare it as a variable. But now this becomes invalid because you can't pass a variable to a pointer, and it don't compile. Oh, it compiled. Okay. Okay, so I didn't say. Okay, it doesn't compile now. So how do you make it compile with avoiding pointers? So first thing you do is pass as a reference, and now it would work. Oh, sorry, this is not a pointer anymore. It works. So, but there is a problem here. If you pass as a const reference, you don't know. If you don't know the function, you don't know what the function signature. You don't know that you are passing it as a reference. So normally, what happens is you copy. If you pass it like this, you create a copy of the animal object, and then the method is called. If you pass it as a reference, it is not copied. The same thing is passed on. And if someone writes into that structure or class into that method, you don't know that. So to avoid that, we pass it as a const animal. So nobody can write in that object. So the next thing would be avoid copies using std move. So you can do using const references because to ensure that nobody would write. But if you pass it as an as I said, if you pass it without the const, anybody can write, and you might not know it that there are changes inside the class or the structure. So a smart way to avoid that is using move. So here you can see that I am using a move std move and passing it as a vector, passing the vector inside this function. So if you remove the move right now and you're passing the r value references. So if you if you pass the value like that, then the compiler would show you an error. It won't compile because it should be moved. So if you pass it explicitly, and you have to move this explicitly. So this is a bit better than the uh, earlier example. It is a bit better because this is explicit that you know you are moving the element, and there might be changes made inside it and you know it. But in the previous case, you didn't know if you pass it as a reference. That's a good side of it. So one more thing would be use smart pointers. That is, if you really need pointers, use smart pointers. This is an example of a smart pointer. So there are three types of smart pointers. One is unique pointer, one is a shared pointer, one is a weak pointer. So in unique pointer, the only one object can hold a resource, like and you can't copy it. If you start copying it, then it won't compile. It won't compile if you are copying it. And if you're passing it to a function, that also means you are copying it. So it won't compile either. So if you want to copy an unique pointer, the best thing would be to use a shared pointer. But if you do know what you are doing with the pointer, and most probably you should be using, and you won't be having multiple references to it, then better to use std move. But if you need a pointer with multiple owners, then you could use a shared pointer using make shared. Then this code will compile now. But the shared pointer has a bit of overhead to it. So there is another pointer called the weak pointer, which has a weak reference to the shared pointer. What is a weak reference? A weak reference is having a non-owning reference to some resource. Like you know that thing is there, but you don't own it. So you don't have the responsibility to destroy it or free it from the memory. And why should you use STD, the smart pointers? Because they follow the right methodology, I say, to allocate the memory at the constructor and deallocate in the destructor, totally abstracted from you. Like this, like right, also can be used in like scope locks. So you can lock a mutex at the start of the block, and it automatically unlocks when you quit the scope. This is pretty useful because you don't need to remember to unlock it after the the code performs. So moving on, uh, there are more new stuff introduced in the modern C++, like the functions as a first-class citizens, structured bindings, still one-liners, const expressions. So what do you mean by functions as first-class citizen? So here is a point structure which normal x, y, and this is just ignore this. This is for printing out the structure. And here we declare a vector of points. So if you now want to sort this vector, the compiler won't agree to us. Functions, okay. It don't work because it doesn't know how to compare the 2 points. So there's a structure is called where I override the brackets operator, and since I override the bracket operator, it can be also used as a function. Compare, if you pass the object, then it will surely work. So these are known as functors, or better as function objects. And these are the way where these are the primitive way of doing functions as first class citizen, passing functions to different methods. So the new way is to do lambda, like cmp, and lambda syntax is somewhat like this. You have a point p1 and point p2, and then just compare it. And if you just pass the compare function cmp, it would work. Same. So these are lambdas. What could you do more with the functions as first class citizen? One more a cool thing that I love is using avoiding if else with functions of maps. So if you do like fn map of 0 equals now, if you pass 0 to the object, it would print 0, and you could just scale it up like this. So you don't need to write extra. Oh. So you don't need to write extra if statements. You could automatically add some a more function to the map and automatically updates itself. So the next thing would be structured bindings. The structured bindings is one of the interesting things which I like because it allows you to do multiple returns like this. You return it as a tuple and then capture it with auto, like A and B, and then pass it with the to the other functions. You don't need to write into. You can also capture it as a tuple like this, and then you need to do something like int a equal to sd get 1, and then pass it the tuple. So this is really cumbersome, and I really like this way. And of course, you can do multiple returns with it, which are a bit abused in my code bases. So other than that, there's STL one-liners, which I would talk about a bit later now. But one thing which is more cool about these days, this new C++ is const expression, which reduces a lot of code. So as you can see here, this is a normal code for factorial, and you can see the length of the code generated for just a simple function. So if we just, let me add a new compiler. So if we add a optimize flag for optimizing this a bit, it does reduce, but nobody uses a O3. Most of us use an O2 because O3 could generate some of the way stuff which we don't like. Oh, sorry, this is not editor 2. I need to editor 2. Okay, this one is the code, not that one. No. Okay, no, that's right. Okay, so this is the code generator. You can see the length of the code. So we can just avoid this and do something like const expression and do a const expression here too. And the code reduces to this much. You can move further, optimize on the code base if you pass an O2. This reduces to only 3 lines of code. This is a new thing which is being introduced in C++ 14 or 17. I don't remember exactly, but this is pretty good stuff. And talking about more new stuff, we have ranges, concepts, and the modules. So a few days back, probably a couple of weeks back, I came across a competitive programming problem on the web, and the solution was pretty ridiculous. It uses a lot of loops, raw pointers, and stuff like that. But so I decided to write it in a modern C++. So in modern C++, you get a library called range, which is to be included in the standard library by C++ 20, if I don't recall. And the problem was something like this. You have a vector of numbers, digits, arranged like this, where this represents 524 and this represents 643. And I need to add this and return another and return the result. So you can see how short the code is, and it doesn't even use a single for loop, but and uses the power of one-liners from the C++ standard library, which is to be in C++ standard library. You can right now, if you use C++ 17, you can include range v3 all from its library by Eric Nibler, as far as I remember, and you can have those functionalities. But in C++ 20, I think it should be available in the standard library. So if you use any modern compiler, you should be able to have this function with an std namespace. So what I do in this function is to declare 2 vectors first, and obviously a carry, and then just write a function lambda, which takes it to integers and takes the carry by reference, and calls the isum. Isum is an internal sum which takes 3 integers and returns the last digit of the sum and the carry. And I capture the sum and the carry with the thanks abusing of the abuse of multiple returns by tuples, and then return the sum. So after that, I just use the ranges view zip with anyone of you, if you ever use Haskell, there is a function called zip with, where you can tie together 2 lists and apply a function on them. And it's pretty similar, which I pass on the first vector and the second vector, and then the sum function, which adds up the 2 integers, passes on the carry, and then it continues one by one, adding up the 2 integers, and at last returns another vector, on which I run and arranges for each loop to print out all the values. So if you run the program now, oops. One more thing. I didn't write any template arguments. It can be omitted in C++ 17. So I need to pass C++ 17. It should, yes, it compiles. And if you print out the number is 1167, which should be this. It's 7, 6, and 11. 1167. That's what you get with modern C++. So the next thing would be concepts. Concepts is a pretty new stuff which is being introduced in C++ 20. Uh, if you take a look at this, so right now you see a concept. I declared a concept here which says if something is passed to it, it should be addable. The operator should be usable. So if I do pass is as a string, it now compiles. This is not the compiler. This is the compiler. So this compiles, and but we don't want a string, right? String also has the str working, so you can pass it and it would still work, but we don't want a string. Oh, yes, but if you pass this two strings, it would work, but we don't want a string. So we can add more constraints like a minus a, and this would obviously fail. The earlier we used to do it like template, write a template function. And TA and TB and return A plus B. So it would still work, but it would fail if I pass something like this. 2 and 2.3 both are numbers, but this won't work because it needs both A and B of the same type. So there is a workaround of this issue is write type name as and pass it as other type if it works. But then this becomes cumbersome if there are a lot of parameters to the add t function. So like using concepts is a better solution, because if you use concepts, you could pass any type which could satisfy this both constraints, and it would surely work for it. It compiles. So and after that there's modules. The modules are coming in C++ 20, but I haven't played with them much. But there are a lot of stuff available on the internet that you can read about, and modules should change the way we package C++ stuff. A good example, I would say, this blog post by Vector of Boole is pretty good explanation of how modules get being used. And coming back to the talk, do you have anything more? Of course we do. So when you compare C++ with the new modern languages, the one thing right on the top which screams round is better tooling. C++ doesn't have any build system, C++ doesn't have any package managers, C++ doesn't have this, C++ doesn't have that. But do we have it? Of course we have, but these are not pretty standardized, so a lot of things go on. Like you can see the build systems. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know how many build systems are there. And out of them, only I think the Ninja is the only build system, and rest of them are mostly build file generators, which are known as meta build system. And make is a general task runner, but it has been used as a build system more or less. And a couple of years back, the situation was so bad that I even wrote one myself. So right now I try to use CMake standard. It's pretty standard. It used a lot in the C++ industry, and in the free software, and I guess in the GNOME and the GNOME communities, the Mason is pretty popular. And in some places, I do find autotools and ascons. I am yet to find Premake somewhere, and probably in Google uses GN and Gradle and something like that. You have to check there. So after build systems, the next question is package managers. C++ does have package managers. I mean, there are a lot of package managers, but if I pick the most popular of them, some would be like Conan, VC Package, and Hunter. I haven't tried Hunter, but it is a bit popular. Uh, and right now at my work, I use Conan, which I don't exactly like. Like everything which uses a multiple scales to multiple stuff, like multiple build systems, multiple type of uh, libraries. It has a bit of learning curve and difficult to use. So I don't like it right now. My choice would always VC package because it is pretty simple to use because it's just a set of bash files and it tightly integrates with CMake. So and it can't be used with any other build system. And you just need to update this Git repository to update the packages. I mean the package list. And after that we have this. So while writing C++ code, always keep this in mind. These tools are really important. One is Clang format, which auto formats your code according to guidelines like the LLVM guidelines, the Linux guidelines, the Mozilla ones too, and the Google ones, I guess. And of course, you can have your own set of formatting rules. The next would be Clang Tidy. Clang Tidy is somewhat like the borrow checker of Rust. It warns you if you are doing something wrong, and if it can, it also corrects you that time. So you also always have Clang Tidy on. With, of course, the set of rules may differ because a lot of C++ code bases are pretty old and legacy code can be flagged as wrong by Clang Tidy most of the time. Coming after that would be sanitizers. Sanitizers is really important. There are different kind of sanitizers like the memory sanitizer, the thread sanitizer, and address sanitizers. A lot of and this allowed you to fix the issues like invalid memory accesses, which get optimized by the compiler sometimes. And of course, the Clang D, it's the LSP client for C++. It's the probably only and the best LSP client present for C++. And of course, a good IDE goes a long way. My suggestion would be to use some like an IDE like CLAN or Qt Creator, or probably if you're in Windows Visual Studio and if you're in Mac Xcode. Somewhat other there are some other IDEs which I haven't used, namely KDevelop and some other proprietary IDEs which I don't exactly remember the names right now. And if you want to learn about modern C++, just check out the YouTube listing of the CPP-Con talks. It has a long list of talks from the last year, from all the years, all the lightning talks are there. And of course, if you want some specific suggestions on whom should you watch, I would suggest the Bjorn, the creator of C++. So this is last year's keynote. It was pretty good and explains a lot of C++, the new stuff which is coming into C++. And the other person I would recommend would be Sean Parent. Sean is a principal engineer at Adobe who works in Photoshop team, and he has a lot of good videos regarding the modern C++. How should you approach modern C++? And there is one of my favorite talks which I'm not seeing right now, but he has pretty good talks. He also has this series called The Better Code, which in every talk he picks a chapter from his book and explains about it. And and he takes examples from like different examples from the Photoshop itself and explains it how they wrote it and how they tackle the challenge. So it's pretty interesting. And one talk I do love watching again and again would be the Gotcha's talk by a Facebook engineer whose name I don't remember right now. Oh, this one is Rebrandy. It talks about a lot of bugs which you might be having in your code base or you might have written somewhere in your code base. So these are just my recommendations if you want to learn more about C++. About if we're talking about blogs, there is an ISO CPP blogs which tracks about a lot of new content like the virtual intelligence C++ conference which should be happening next month. Uh, there, if you are into podcasts, then obviously CPP cast is the best choice out there for C++. And of course, you can always reach out to me if you want something more. Thank you. So,
Great.
Ayan,
We have a couple of questions in the chat if you want to take that.
Is Hellozy muted or is this just for me?
oh, sorry. Uh,
Oh, you muted.
so,
Okay.
in CPP and CC files, talking about CPP and CC files, they both are same. I prefer using CC files because I don't know why. I like them just. But in my company, they use CPP, so I have to do CPP there. Why not be using a deconstructor? I don't know what is a deconstructor, but as I googled in, I found probably you meant desk deconstructor. I don't know there is a deconstructor in C++ or not, but if you mean destructor, then of course.
Oh yes,
Uh,
mean I mean that, yeah.
yeah, so in smart pointers, it automatically deallocates your allocations in the destructor. So same thing. Can you suggest some resource or book where I can read about this? Of course, as I suggested, the YouTube talks, mostly CPP conf videos. There are other conferences too, like C++ on C, C++ now. There's one conference happening on St. Petersburg. I don't remember the name exactly. It was something around CPP Peter. Uh, okay, from YT, what's YouTube? Okay. What are the concepts? Please explain. Concepts are just constraints placed on the templates. So if you run into something like, I'll show in the code. Okay, list. If you do something like include algorithm, include list, do like list and L, and then try to sort the list. This would never compile. And I don't know what the situation right now, because yes, you do get a bit of garbage, which you don't get to understand anything of it. But if you use concepts, the concepts is a better compiled messages. Like it would tell you that you can't do a list, a sorted list like that, because this doesn't allows you random accesses in it, and you should be using as list.sort for sorting out stuff. So it would work now. Yes. So that's why concepts are important. And what's the state of async in C++? In coming C++, I don't know whether it included in C++20 or not, but there is ASIO in. I think there is a network library on based on ASIO, uh, which in the deals in asynchronous I/O with some network stuff. So it's definitely coming on the async, and along with ASIO, there are a lot of new stuff like STD, SIMD for the it already included in C++, XTD, SIMD stuff, which is copied from VC, I guess. So of course, and talking about other stuff like along with STD, SIMD, there is STD audio, STD audio. So there is STD audio coming on, which allows you to deal with the audio in standard C++ library. There is always STD IO2D for doing 2D stuff, like rendering 2D primitives using the C++ standard library. So yes, a lot is coming in the C++ standard library. Any more questions?
Scroll down.
Okay. Oh, are there new good security practices I need to learn about? New to C++. I am not quite sure about the security practices, but yes, by writing less code, you are writing more secure code. Try to use the standard library as far as you can go, and of course, there is more stuff I can't exactly remember right now. Uh, I don't remember exactly. There and some new stuff I forgot about. So the new thread modules join thread automatically. Yes, the new thread modules join. This joining thread, I guess, STD joining thread. Thread. No, 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 no. I forgot the new thread modules. So yes, any more questions?
I think it's JThread.
Oh yes, JThread. It automatically joins in the destructor and follows the RAI principle, the RAI, resource allocations, initialization. Yes, that's it. Okay, I think we are done with questions.
Yep. Awesome. Thanks a lot for the talk, and it was a good session. Hopefully, we'll
Thank you.
have the recording up by tomorrow. And we have volunteers call coming on Tuesday as usual. And then Friday we have the community check-in. On next Saturday we have a talk on Docker by Manav. So if you could give a small intro on that, Manav, now's the time.
So the talk is mainly going to consist of basics of how like so I have read a lot of stuff about Docker, and everybody like I personally felt that it is very stigmatized in a way. So everyone says it's just containers. Nobody just realizes what the essence of Docker is. I'm going to try and cover the essence of Docker starting from the very beginning.
Awesome, thank you. Looking forward for that. So yes, on that note, we can conclude the meetup. Thank you everyone for joining, and see you on Tuesday. Bye
I
bye.
think we have some more questions from YouTube. Just wait for a second.
Okay, sure.
So the question is basically why India is still stuck on Turbo C++. Why our college is not teaching about C++ 11, 13, or 17.
Cause they are switching to Python, of course. Earlier it was Java, and now it is Python more in the academic world. So they are mostly switching to Python these days and throwing away C++ courses. But it would take a bit of time. So, any more questions?
I think there are no more questions.
Okay, so we can call it off.
Sure.
Okay then. Bye. Good night.
Bye.